Let's consider a fast-moving car. Let's say that the car is moving with a velocity of 100 kilometers per hour. And the car, due to some reason, presses the brakes and it stops within 55 meters. The final velocity is 0. What should be the average force acting on this car? Well, to calculate the force acting on the car, the net force, the magnitude, will be the mass times the acceleration, or in terms of the vectors. If we want to calculate the net force, first we need to determine the acceleration of the car. Well, the acceleration of the car, the magnitude, will be, let's say, this is the positive x-axis, it's a one-dimensional motion. The final velocity of the object is 0. The initial velocity is 100 kilometers per hour. Or let me just use v0 for the time being, divided by t. This is the acceleration of the object. Well, we don't know what t is. To calculate the force, we need the acceleration. To determine the acceleration, we need to determine how long it takes for the car to stop. Well, we have one more information in this problem. We know that the car stops at a distance, within a distance of 55 meters. So the final position is 55 meters. Let's call it x. The initial position is 0 plus v0 of t plus 1 over 2 a t squared. This is the displacement of the object. Well, rather than using the t, we can just solve for t over here and substitute it here. So the time it takes is minus v0 over a. X will be v0 of minus v0 over a plus 1 over 2a minus v0 over a squared, which will be minus v0 squared over a minus 1 over 2 plus 1 over 2 v0 squared over a, or minus 1 over 2 v0 squared over a. So we can determine the acceleration. The acceleration of the object will be minus v0 squared over 2x. We know v0, it is 100 kilometers per hour, minus 100 times 1 kilometer is 1,000 meters. 1 hour is 3,600 seconds squared. This is our v0 squared. 1 over 2, well, x is 55 meters. So the acceleration of the object will be minus 7.0 meters per second squared. You see here we have a meter squared. It will cancel with one of these meters. So there's a single meter left. And here we have a second squared, meters per second squared. The units are consistent. They are correct. Now we know the acceleration. Now we can determine the force. The mass is 1,500 kilograms. The net force will be, the acceleration is minus 7 meters per second squared. Kilogram meters per second squared is newtons, so this is minus 1.1 times 10 to the power 4 newtons. This minus sign basically indicates that the direction, since we had chosen the positive direction as the direction of the velocity of the car, these minus signs here in the net force and also in the acceleration tells us that the force acting on the car should be pointing in the opposite direction. So if the car is moving towards your right, the force is towards the left and the acceleration is towards the left.